I can see like some people are getting worried about the pay. So if you go to the settings and the plan and the usage, you can notice the amount of usage that you have happened. If you scroll down under the settings and the billing, you can see the Codespace usage. For every month, like you get a free time. Under that free tier, you can do for 120 hours. 120 hours means like per day it is 4 hours. So don't worry. So you can do it as much as you want. And even in terms of storage also, we have to the tune of like 15 GB. So with this, it is more than sufficient for your practice if you are planning to use the code spaces. So, and like for everyone, if you didn't start a code space, it will happen. But like subsequently, you can start one. So if I open this code space, and again, we can delete a code space also if you don't need, and you again can up it. So the beauty of creating a code space is like, so everything will be intact. So what are the changes you do locally, it will preserve, and it is persistent enough. But initially it will take a moment to load because it need to spin up, right? That's one thing. Next, so in every repository, I mentioned the what all things were done and the the corresponding video also adjacent to it, so that whenever you're going, it's easy. So yesterday we have seen about the bitwise operations. That's the last thing. So then like after the bitwise operations, we have something called as identity operations. Under the identity operations, we will look for something called as identity ops.ipynb. Okay. So initially it's trying to detect the kernel. Not we can mention it. So once done, close others. So fine. Identity means you are trying to identify an object individually. What are the things that are happening, and everything will be happening at the object level. So till now, you know that every object will have three things at the minimum. Means at the minimum, it will have a value or values, data type or like types, and address location or address locations. So why you are telling values, sir? Till now we are going for individual values, but down the line you will go for data structures also. That's the reason I mentioned the word called as values. At this moment, think that till what are those are basic data types. So I told that there are three types of operators. In operations, we have three things. Till now, we know the assignment operator, which is a single equal to, and two equals, which is a value level equivalence. Apart from this, there is a third one called as object level equivalence, called as is operator. So this also will tell in terms of object level things. What is that information it tells? Let's see. If I have an example of 4 equal to 4, the value is true. Whereas if I say 4 equal to 4 as a string, if you go to like loosely typed language like JavaScript, it says yes. But here in Python, every time when you're doing a value level equivalence, it will check not only the value, the data type also. See, value and type together. As the type is and value are not equal, so it will not say it. Is it the case then why we need to go for a is operator? Because equal to itself is doing right what we need. It's okay. So if you do the same thing in terms of objects, is not needed in this case, but still if I use. So is will check the object level both are equal or not. Generally, Pipette recommends don't to use. So it is saying like a syntax warning. You see what it is saying? hey, you working on a pure variables, so pure values, right? So then what is the point of thinking of object level equivalence? A 4 is a 4 everywhere, right? So in the same fashion, if we say like, 4 is 4 as a string, for this also it will say false. But apart from that, it is giving a warning. You are seeing the warnings for the first time, right? Okay, then is operator in which case it is primarily used means, generally they say that, so equal to you can apply everywhere, but is should be applied on a variables. Means if I have a number 1 which is having a value of 4 and number 2 which is having a value of 4. Now for these two I can do number 1 is number 1, number 2. Like this I can do, which is supposed to. Means is generally recommended to use on variables. That's one thing. Then what is this it is uniquely doing means, I told for every object there will be three things. If you want, so the value you go with the number 1, you get the value. And if you want the type, you have a type built-in function. And if you want address location also. If I do the same thing twice, means for both the objects, say number 2, number 2, number 2. Did you see that? For every time, both the times, integer both the times, and data address location is also the same. Now let's explore a bit more into these address locations, how it would be different. If I take the same values with the different values, okay, I want to check here in this case, both like, so is equal to 0 and also this one, both the things I want to check. Say like print of, I can do an F string assignment, right? That's the easiest way. So that I can do everything, I can get the result also. You see now what happened? Oh, I'm saying equal to, right? It is doing a minus. You see now what happened? You see what happened? Is equal to, so this means it's true. Value is also true. Now we understood this concept. Now let's do the same thing for a broader perspective. You will understand. Let me do the same address locations also displayed. So everything in a single block. For different values, I will try. In one shot, you got, as both are 4, values are equal. In terms of address location is also same. Fine. Now for the same thing, I will make a slight difference. Instead of 4 as a value, I will make 4 as a string. Now if I ask, it says in terms of value also both are not equal, address also not equal. So different objects were created. This is also fine. So let me take this time the same values, but say some 56 I took. Some random value 56 I took. Both are of same values. Observe very, very interesting point I will tell now. Both values are equal. Address location is not changing. Means when you define the same variable twice with two variables, what do you expect? It should define two variables, right? But did you see that it's not creating a new variable? It's reusing the existing variable. So now let me repeat with some other value. Say like instead of 56, let me go with some 300. And if I execute like this, what happened? Did you observe some interesting point here for the first time? In terms of the value, both were not equal. So in terms of value, both were equal. But in terms of address location, both are not equal. What is this happening? Means earlier, sir, when I did a 56, both are same values, but two same address location were there, right? Both are. But when I gave the 300, so values are same values, but why different objects were created? Before giving a conclusion, let me give you one more example, then you will understand. So to understand more, yeah. let me give another number, say like some 256, 256, some number I give. Did you see something happen now? Sir, what is this, sir? Sometime it is working one way, sometime the other way. Means when you do the 56 both times, both in terms of value and address both are same. When you did 300, address and value both are not same. When you did 256 again, address and value are same again. So what is this? And if I do like a 257, observe what happened. I think with this you get some clarity. So when it is 256, so when you define two variables with the same value, instead of creating a new object, both are referring to the same object. Whereas the moment you give 257, both are referring to different objects, right? Means there is some boundary with 256 and 257, you understood. In the same fashion, so if I go for like, negative side, if I go for say -5, -5, -5. So I'm asking, hey, what's the value? In terms of value, so both are equal. Address location also say both are equal. Means new object is not getting created. But if I go for like -6, this is a very, very unique concept which you don't generally know. So the moment I did -6, it became like this. Means in Python, there is a concept called as a dual memory management strategy. This is the most important point you need to be aware of. So there is a concept called as dual memory management strategy. What is this dual memory management strategy? Means generally for better management of code, they have gone for this kind of scenario. Yeah. What is that means? Between -5 and 256, only for the integers, between -5 and 256, whenever you are asking, they found that, most of the people, when they are writing programs, they create variables. So with some values, right? When you are creating a value, it should store in the memory. First create and store in the memory. So as these were like most commonly used, they decided that, as this is for better reusability, between -5 and 256, if you define any variable 10 times or 20 times, so instead of creating a new object, all will refer to the same object. But if you go outside, generally it will create, for every object, it will create a separate variable. So that is what's happening. Sir, will it work for the floating point values also in the same way? Let's see. So if I go for like this same values in a floating point values, I told these things were there only for the thing. Means between this 5 and so and so. Let me give the 5 again. 5 again. But this time 5, say like 4.5. So I can give like -4.5. But did you see what happened? So different objects were created. Means for floating point values, it makes no sense. Even if I go for like, so just real time, 1 point, say 10.2, second one also 10.2. I gave some value in random, but what happened, did you understand? For every time you are creating a new object, it will create a new address location. So that is what about the dual memory management strategy, which will be applicable only for the integers, only between -5 and this thing. Now, next, one more thing happens. This dual memory management strategy, what it told is like one more point. There is a concept called as mutables and immutables, which you learn shortly afterwards. So I think you already learned a bit about the mutability and mutable objects concept. Means any object which supports in-place changes is called as mutable object. Any object which doesn't support is called as immutable, right? Hope you remember I already told this concept when you are working with strings. So if I say in real time, mutables and immutable objects. For immutable objects, the same thing works. Say, till now you know the concept of immutables, but down the line you will learn more about these immutables. The most important thing is strings. String is an immutable object. So integers are like a immutable objects. Floating point, so these are immutable objects. So these are like basic data types. Down the line, you'll learn about something called as a tuple. Similarly, mutable objects means till now in place changes you never did. There is something called as a list. Next, you will learn about set and a dictionary. These are something you will learn. So at that time also you can understand. Means, let me take an example. Say, though I am making like number 1 because I don't want to change everything. There is something called as like this. This is called as a tuple. And if you place with a square braces, it's a list. If I have more than one value placed within the square braces, it's a list. I told this is a list. For list, what happens if the values are same? Did you see? So a new object is created every time. So both are separate, right? False. Similarly, instead of a tuple, instead of a list, if I go for a tuple, once you go to those, you can come back again to understand more. If I execute right now, did you see what happened? So like that. So for the different complex objects also, you can check and see. So this is all about the identity operation. Now, next going further into the next one is called as a range object. So 06. So this is one of the most important because every language supports some way or the other to work on these things. Range function dot ipynb means every language will have some kind of sequence generator. So in Python, we have this range function. So in fact, it is a built-in function and it has some things. So the point about this range is that it's a built-in function. It is used for the sequence generation. So hope you remember the concept of how we did the slicing. We have a starting index, we have a final index, and we have a step. And we walked among them, right? The same thing rules we will work here. And also the most important point here is that if you want to get the values from this, either you need to do a for loop to get all the values, or you need to do like convert to another data types. So I will tell you that. So there is a new concept called as lazy loading objects. What is this concept of lazy loading? How it can help you? Let me do it. So if I go for this range, if I need to get the help, there are two ways. You can use the built-in help function, you get the help, or else after the object you give a question mark. I gave an help, so I got the entire details. So you can give a single value, which is a stop value, or three values. So it's start, stop, and step. Either way you can give. That's what it is saying. Now to start with, if I say a range, because it's a callable function, I can do a call. Because like if I just make a call like this, I'm getting like this. But how can I know whether an object is callable or not means? There is a built-in function called as callable. If you apply on any method or anything, if it is callable, it says callable. Then if I say range, you can see that it is saying, hey, expected at least one value. You can give more than one value, but at least I need one value. So if I give like one value, which is a 9, it is saying what? Hey, you're gonna get the values like this. Or if I say like, two values, means the stop value is 9, it is mentioning whatever we have taken. But the defaultly start is 0. If you explicitly give 0 also, it will give like that. And there's this step also. The default step is +1. Even if you give also fine. Okay, sir, this function is executing, but where are the values? So in Python 2, so this range function used to give all the values. Just imagine if I say range of 9, it should give the values from 0 through 9. Means how many values? Some 9 values, right? So what if I say range of like 1 crore? So 1 crore value should generate and store in the memory. Don't you remember that, this memory will be burdened too much when you have more values? To optimize it in Python 2, they introduced something called as xrange. The same xrange of Python 2 is called as a range in Python 3. And in fact, if I assign these to some values, so you can notice that also. If I give one value and if I asking, hey, what are the values? If I ask values, you can see. So whether you call directly or whether you give indirectly, it is doing the same thing. So what it is happening, I told you already. When you give a single value, it is treating it as the final value or the stop value, and like it is doing the remaining as defaults. So I told that this initial default start is 0. So default step is +1. So you get it. And when I'm asking the values, I got something. So if I ask like, hey, give me the type of values, and the values, you can notice it's a type range. So you are seeing a new object right now. Till now, you know the int, float, long, string, all these things. Whereas the range is a new data type. So whereas if I give like a 2 values, so the same values is equal to range of 0, 2. Then how it is treating? So what are the values you are given? It's thinking like, start and final value or like initial and final value. So, and like step is taken as default. Now in this case also you ask, hey, what's the values and the types? Again, range 0 to 9. So if I give like all 3 values also, the same logic it will think. So means if you give 3 values explicitly, so then also it will take and give the things. And if you are asking like, hey, give me the values, type and the values, you see what happened? It is of range type and so on. So then how do you get the values? That's the first question. If you want to get the values, you need to do a for loop. So in Python, it's a very simple for loop we have. So there are 2 types of for loops generally. Anyhow, I will go detailed and tell. So we don't have like a I equal to 0, I plus 1, like a typical C language kind of for loop. If you have an object, you can for loop on it. So I can say like for each element in, so values, print of each element. If I do, I get all the values. Like I can define in any of these 3 ways. If you give a single value, it will treat as a final. If you give 2, it will think like start and final. And if you give 3, it will think like all 3 were given. And you got the values. Or alternatively, if you want like the values, either for loop on it or convert to another data types. There are built-in functions called as the list, tuple, and set. Correspondingly, they will convert to their data types. I told you already that list is something which has a multiple values collated together in a single square braces. Whereas tuple means all those values collated together in a parenthesis. Whereas set is using a flower braces. Okay, each has its own advantages and limitations. We are not still into that phase. When you go there, I will tell that more. But so now I understood one thing. Whenever I am creating a range, so temporarily to understand, I define the value and instead of printing the values, I convert to a list such that I can notice what values are generated. So first, let me think of how these values are generated. Someone can help me. So say how the values would be. Anyhow, you convert to a list. So the result will be a list. So what is the starting value? 0. 0 plus 2 is 2. Plus 2 is 4. Plus 2 is 6 plus 2, 8 plus 2, 10. But the last value is 9. So it will go here till here. Did you get the same values? Right? Next. So if I go for like one more values, you should tell me this time. So same like this. Let me go with. Can someone tell me the answers? What would be the values? I told it should be a list because I cannot do list. The
0,
value
3,
exactly
6,
6 and 9.
9.
But like 9 is the last value, so it doesn't include the last value. It's a good take. Let me take one more example this time. What if I mention like this? 0 to 9 with a step of -1. Of course, the result should be a list. From 0, if I do every time -1, what will I get? -1, -2, -3 like that. But were those results within this 0 to 9? No. So that's the reason I don't get anything. I repeat again. So you need to do the operation, but every value should be within the limit. If they were not in the limit, you don't get anything. Or else, let me take one more example. This time you should tell me better. So what are the values? It's starting from 9. So 9 minus 1, 8, minus 1, 7, minus 1, 6, minus 1, 5, minus 1, 4, minus 1, 3, minus 1, 2, minus 1. And like, next minus 1 is 0. It will go till last value, but doesn't include last value. The same thing holds even if you ask like this. As you ask till 0 here, you got till 1. But if you ask the same thing, so but here, you're going to get the values in the other way. Even 0 is included because you're asking till -1. So 9 till -1. Similarly, if you ask the same values, say from till here -3, you can write. So what is the values? 9 minus 3 is like 6, minus 3 is 3, minus 3 is 0, minus 3 it won't get. Hope you got all the values. But so you need to understand some things that we cannot do. So we cannot have a floating point values. Floating point values can't be there. So either for the step or like you cannot have like the starting and final index to be float and step is like that also you cannot have floating point values. Or like you cannot have where all were like floating also, in that case also you should not have. So floatings are not at all supported. That's one thing you should be aware of. And also there were some interview questions which was asked. So with that I can close it. So what if I ask range of 9? So range of 0. So when I am defining like this, what it gonna be? So when I don't give, the starting value will be 0. As what single value if you give it treats like a 0. So starting is default is 0, final is 0 as you give, and 1 is the step. Nothing will happen. So you got like empty. Similarly, if I do the same example, so with like, hey, 0 to 1, sorry, 1 to 0, sorry. In this case, it's gonna do what? Same like this. So here, so what would be the starting value? So you have given as 1. Ending value is 0, but step is 1. What you will get? You get nothing. So whereas slight change if I do, like if I ask, hey, 1 to 0 with a step of -1, means as it is going in the direction, so 0, 1 minus 0 is, so 1 minus 1 is 0. So at least you get one value. So like that, these are the edge cases to get anything. And not only this, when you have a object like a range object, you can do any operations on it. Say like, I assign to a variable called as the R, and if I print, I get the values. And by default, you don't get anything. But with this, we can do some kind of operations to get the values individually. So means like I can ask, hey, what is the start? What is the stop? And what is the step? Like that, I can ask individual values. Or else I can also check for a particular value is present within it or not. Means you told 0 to 20 with a step of 2. Let's generate the values. If I convert to a list, I get it. But still, I don't want to. But so if I mention like say list of R, you got all the values. Now within these values, I can check for something. There is something called as an in operator I told. This is called as a membership check. I can check for something is present or not. Or like I can get the count of a something. So how many times a particular element occurred. So if that element is present, it will give. So is 11 present here? No. That's why count means it is saying 0. Whereas if you ask 10, it is saying 1 time. And if you are asking the index of 10, means the position at which it is present. So 10 is present at the 0, 1, 2, 3, 4, 5th position. That's why it is giving 5. So like that, you can ask. You can also do like, other operations like indexing, slicing, all those operations you can do. So, and also a couple of interview questions just to mention. So range of, we can compare two range objects also. Range of 0 means it will give 0. Range of 2 to 1 with a step of 3, that also makes no sense. It is also giving empty. So directly they both may not be equal, but their end results are equal. So that's how things works. So with this, I want to stop and let's join. So next, so we see is on the conditional operations. In terms of conditions, generally we know that every language will have the conditions. Means condition means if condition, else, if else, elif, ladder. So, and like ternary operations. All of them are like conditions only, in fact. So if you want to learn more about these conditional operations, let me go one after the other. If I take one example of a typical, say, IP1B, NB5. And if you see here, you can understand that, a typical condition, how it works. These conditions works on the basic things till whatever you learn. Means the relational logical operations and all these things. Based upon that only we work on it. Somewhere there should be some logic. Based upon that logic only we need to do. Let's say I have a problem that I need to check. So whether a given number is even or odd. And this value I need to get in runtime and I need to do. So this is all my basic thing. For suppose like if you want to get the value in runtime and work on it. So how do you check whether something is a even or odd? First, that part we need to check. To understand that, let's take a number is equal to 34. And if I print the number, so now obviously it will say number is 34. But if I say number divide by 2, it will say what is the result. Or like, so if I want all kinds of results in one place, let me place like this. I get a number divide by 2, which is a true division, which is a floor, this one. And in case, there is one more thing called as floor division, right? To get the quotient operation. That also I can do. But did you know one interesting point? I have 34. When I did a pure division, I got 17. Flooring division also, so I got 17 only. But when I did like divide, means remainder, I got a 0. Because it is 34, I am getting like this. And if I do the same thing operation again, so with like instead of a 34, let's say I'm doing for 33. This is an even. Every time when you need to write a logic, you need to think of how it works. So if I execute, did you understand one thing? This ordinary division and floor division makes no sense. You got some result. But for the reminder, you got 1. So you understood that reminder 1 comes for odd numbers. So reminder 0 comes for even numbers. Means what? For any number, you can check whether the reminder is equal to 0 or not. That's what you want. If I say number is equal to same 34, so I can purely check this one. So similarly, if I define like different numbers, say 33 I define, say minus 30, minus say minus 36 or 35 I am defining, whatever numbers. So as it is a even number, even reminder is like 0. So that's why it is true. So reminder is equal to false. It is not equal to 0. And this is like false because it's not reminder. Means for the odd numbers, the reminder will be like this, even number the other way. With this logic, can I define like if number not equal to 0, can I say number is a number is non-zero, right? So similarly, if the same logic I can do in other way also, right? Hope you remember. For ordinary numbers or any data type, the basic check is like whether it is non-zero or not. For string, if it is an empty or not. So that one we can do implicitly also like this. So there are two ways of writing a condition, whether a number is non-zero or not. Then what kind of things it will evaluate in the backend? If I do these two checks, so it will check. If I do like this, this is very popular and powerful that it will check for all these conditions. So it's not just like number is a even, it will check even for all these things. So number is not equal to 0, number is not equal to false, number is not equal to 0, not equal to empty string. It can be any data type. But for now, we know that. So this is implicitly, this is a very powerful operation. Similarly, if you want to check whether number is even or odd, for that condition, so we should say like this. If I want to check whether a number is odd or even, I can do like this. If the remainder is equal to 0, I can do like this. But if I do the same thing, explicitly without 0, then you should be very careful. It is not an even. The reason, so when you are checking like this, any number, you check for the end result not equal to be 0, right? So this is equal to this one. So then like when it will be not equal to 0, when it is an odd. So that's why you should be very careful about this one operation. Hope it's clear. So when to use this way, when to use not to use this way. Hope it's clear. So explicitly, and every condition makes a difference. Now you see here, every number you define, you can do it like this. Now finally, I want to write a condition. Means if I want to check the same thing, not just with an if or else, I can do with one logic like this. Means, so explicitly if I want to write, I can write like this. So is equal to 0 means it is an even. If not, it is so and so. Like this also I can write. Or I can rewrite so in a different ways. So if I do like in a rewriting, I can do like this. Is equal to 0 means it's an even. If this condition is failed, it is an odd. And the vice versa means if it is not equal to 0, it's an odd. Means if this is not satisfied, the vice versa. Means it is we, the human beings, who are writing the logic. We can write in whatsoever which pleases us better. Hope it's clear. Any doubt till now? Fine. Now, based upon these things, now write some a couple of functions. So my request is that I have done this value in a runtime. Oh, so one thing we forgot to get these values in runtime. How to get the values in runtime? Number is equal to, use the input built-in function to get the value. So enter any number. But like, it will give, input will give like a string. but we want to convert to an integer. Then convert to integer. Then you write this logic, whatever you have, either the first one or second one. So if it is even or odd, that you want to check. Finally, if I say 56, it will say 56 is even. If I give any number, it will check whether it is a even or odd, and you get it. Now enhance this example. So I am giving a small assignment. Is that you generate the even numbers between 45 and 137, and you get it. So to do that, first you need to generate the values between 45 and 137. So for that, you need to just go to range and get the values. So means like it's a very simple example. So you use the range built-in function to get the values. You are saying like, hey, 45 you want and 137, right? 147 or something, 137. If I generate, I get the values. So what I need to do? I need to for loop. So each number in, and I can do a print. Each number, I get the values. For each of the number, I want to check whether it is positive, even or odd, right? How do I check? I divide by 2 and get the remainder. So we as a developers need to be aware of what operator to use at what point. So first you need to know the logic. What is an even and odd? It is not Python which is telling what is an even or odd definition. General math. So based upon these values, so when it will be 0, when it will be non-zero. When it is 0 only we want, right? Is equal to 0. I checked it. So I got for some of them it is a true, for some of them it is a false. Now you need to add the extra stuff, which I don't want to do. You write an if condition to get only the even values, right? So now modify this. Slide, you need to know where to place the condition. Update it. Similarly, if I want to go for the next interesting thing, which is a number guessing game. So generally we play number guessing game multiple times. So like a lottery game we call. So like for fun we play number guessing game. So means like you were given one lucky number, which you need to guess it. So let me start with a small code. First, I need to define one lucky number and I need to give some values. And every time I need to try to guess the value. This is my ultimate intention. So I think like for this particular problem, rather than solving like this, so let's do the other way. So using a IP.py file, because till now you are working all the way with these numbers, right? So with the typical way I'm doing. If it is a I.py file, then how we do it? The shebang line, which is not mandatory, but this is how the general structure for the shebang line works. And you can write. And you can write the purpose of the program, which is like a typical number guessing game. So where you will be given a lucky number and you need to guess it. So first at the top, I told like the constant should be at the starting, which is the lucky number. I defined something like it's 69. So every time if you want to change, just change the value there. Similarly, so user also will have some number, right? Say like guessed number. Guessed number. User also will guess a number. How to guess a number? We need to use the input built-in function to get in runtime. So enter a number. Say we need to have a fixed and finite limit so that it's easy between 0 and 100. So inclusive. Inclusive means it can be 0 or 100 also. So now how do you run this program? You need to go to the terminal. If you open a new terminal, it's gonna work. So we need to navigate to this directory where your file is there. Clear the screen and observe one interesting point here. When I created a file, I created a double extension .py, right? I made it clear now. Now I have gone to this directory and I'm asking, hey, Python space b so and so. So it gave the number I gave some 67. It gave. Because I am not consuming much, I can just see it. So if you want, like, I can print the numbers, like what is the lucky number, what you have user has given, and what is the guessed number, which we are doing user as an individual, how they are passing. And we can check like both are equal or not. How do you check both are equal or not? So guessed number is equal to lucky number, right? That's what you want to check. I use like, F string assignments. Did you see F string assignments are so handy? If I execute again, I give some 45. You see, it is saying that lucky number is 69, whereas the number you have given is like a 45. And 45 it is like a string. It is the REPR representation. Due to that, now I understood that, hey, I gave a string instead of an integer. And we know that int built-in function every time will take like a string. If you want to convert an integer, we should explicitly pass the int built-in function. Now if I execute again, if I gave some 56, now did you see? It was 67, 69, I gave 56. It has made a check. Both are not equal or means it's false. So now I understood that there is a condition. So based upon this condition, I can do one thing. So in the method one, in the initial way, I know that this is a condition on which we are determining. If this condition is true, we are saying that you guessed it correctly. If not, you are not guessed it correctly. So based upon that, if guessed number is equal to lucky number, so I can tell like, hey, you guessed it correctly. So I like this, I wrote a small program. Now we see it's very interesting. So if I clear the screen, I created a small game. Now whenever user is executing, so user will guess some number. If the guess is correct, you will get an answer. If not, like this. If I guess again, say 67, again it's not correct. So my guessed value is like, so 69 again. So in this case, it is saying you guessed it correctly. So don't you say a small game is good? But you see, like, if just we have 100 values, the probability of we getting success is 1%. Means 99 times you get a wrong value. So don't you think like, continuously, if you know 69, luckily fine. But what if I'm starting somewhere at the 34? I give some random value every time. I don't know what's happening. So whatever the guess I do, so I won't get any value. So over a period of time, I get like, reclusive. I feel like, bored. What is this game? Whatever I'm doing, it is not giving any answer. So you don't feel comfortable, right? So in this case, so instead of writing a single condition, that's where we need to go for a if and else. So, okay, in every case, whenever the user is guessing, if it is correct only, you will display. So what else I am saying is that when you create a small game, the best practice is, okay, when things are good is fine, but at least give an acknowledgement that, you didn't do well or try else next time. So that user will understand, right? Okay, I executed, so it took the input, but the output is not correct, right? So of course, we should not reveal these answers every time. So let me comment it. If I give to someone also, it should be easy, right? So if I give like some 34, at least it is saying now try again. So at least I'm be happy that, it worked. Else what I will think over a period of time, if nothing is happening, okay, maybe this game itself is not working, he will think. So now he will think like, try again. So try again. Okay, try again is good. When you are correct, it is saying correct. So, but like, sir, why you got two answers? Because you have two separate conditions. So one of them, if you want, only one you can do. So you can, comment one of them, and if you execute every time, that's only works. One advantage you can get in this process is that things were more accountable. So, when you give, so when it is correct also it's fine, false also it's fine. But one issue here is that, so, okay, every time you are getting try again, over a period of time, people will be vexed with this point also. too many times try again. So to avoid that, so in real time, we can go for a leaf ladder. Means whenever you are getting like this, means when it is correct, okay. So, but when the value is not equal, you can think of 2 points. So you have seen that lucky number is 69. That's what I wrote in the top. Now user can enter like, some 45 or like, some 89. What is this point? When user has given 45, he is way below the guess, right? His guess is way below. He need to improve his guess, right? He need to increase the value of guessing such that he will come closer towards 69. If the user has guessed like 89, they should reduce their guess such that they will become 69, right? So like this to get it, so we can write two conditions. This concept is called as like elif. Elif means like else if. In Python, there is nothing like a else if. There is something called as elif. So beginners will just confuse, just be aware. And also one more point. Did I ever mention that else condition here? So no, I didn't mention. So you need to understand one more point that, so else is an optional. Else block is optional in Python. Else block is optional. If I execute right now, this is the most interesting way. And I should not have a repetition, so I'm commenting this one also. Now I have only one option. I'm taking the value and I'm printing. So you see now, it became perfect game. If I say like 34, it said what? Hey, please try again by increasing your guessing number. So from 34, next I will give 44. So it is saying like, oh, sorry, I need to run. So I need to give like 44. I gave. It is saying increase your guessing number. Then I understood the value is between, so 44 and 100. So then I gave like 55. It is saying like increase your guessing number. Now I understood the result is 55 to 100 somewhere. So then I gave like, so 78. It is saying reduce the guessing number. Now I understood more clearly that the value is between 55 and 78. Now if I give like, some 70, it says reduce the guessing number. Now I understood the value is between 55 and 70. So now if I give some 65, now I'm much more clear that the value is between 65 and 70. If I give some value in random, say 67, it says increase your guessing number. So now I understood between 67 and 70 the values. So if I give all of a sudden some 69, yes, you guess correctly. No, I am making the user to come towards the end, right? Of course, user took a lot of options. Maybe once you go to the while loops, I will add a condition of in how many chances you have came to the conclusion. But I engaged the user, right? So this is how I created a smart small game. Hope it's interesting. You created a small game. So let me go for one more real-time example. We can go for something like this. Office schedule. What is an office schedule? How we need to get it? So typically, so we have a office schedules. So everyone has an office, whether you go to or not. But like every office will have some office schedule. Let me create a .py file. This office schedule is like this. Monday to Friday they have like this. Saturday like this. Sunday like this. So what is the input means? So in runtime, so user will give week name, and they should get that week, that day schedule. Okay. If I give like Monday, I need to get the Monday schedule, Tuesday schedule, Thursday schedule, like that. So let me take the initial value, say week of the day is equal to Monday. I'm taking some like, some variable, week of day. So for this week of day, I'm not making it as a constant, not capitals, because I want to change. So how do I implement this logic? For every day, I have a particular timing. So based upon this, what I can do, if week of day is equal to Monday, then like what is the timings? So timings are like 9 a.m. to 6 p.m. I wrote it. And we have like a elif, right? Elif. Week of the day is equal to, say, Tuesday. So then what? Of course, for Tuesday also same timings we have. So similarly, till Friday we have the same timings. So the same thing I will repeat again and again. Monday, Tuesday, Wednesday. You may ask me, sir, the same value we have for multiple conditions. Till now, I don't know a better strategy. So till whatever I learn, I can use like this only. But for Saturday, we have like something. So what Saturday, 9 a.m. to 1 p.m. I wrote it. And for Sunday, it's a holiday. For Sunday, it's a holiday. It's good. So is else needed? No. We need to understand that, else is optional. Else is optional. Means when you need, you use it. Maybe I thought like it's not needed in this case. That's why I didn't use it. Initially, I go for asking schedule. Okay, it is constant, fine. What if I change this value to get the value in runtime? So how to get this value in runtime? So instead of getting like this, I can comment and ask the value in runtime. When you want to get the values in runtime, we need to use the input built-in function, as I told you. If you just use input built-in function, you don't know what's happening. It is waiting for our input, but we don't know. But if you give like within the input some value, then that value will be printed in the output. So users can understand, okay, he is asking to enter a weekday. So user will enter like Monday, you get the timings. So like user will enter like Tuesday, you get the results. User will enter like, Friday, they get the results. So user will enter like Sunday, they get the results. So fine, right? Sunday means like, oh, I gave Sunday, but I didn't get a value. Did you observe what happened right now? Till now, everything is fine. Friday also got, but Sunday, why didn't get? I gave Sunday, so it is also Sunday. But what happened? There's a case.
Capital S.
Exactly. Case difference is there. How to handle this problem? So we need to write like 2-3 ways, maybe. Means like is equal to like this, and so or so can I do like Sunday right now? Maybe now it works. If I give like Sunday, it works perfectly. What if next the user has given like QNDAY? So will I write that also like this? Weekday is equal to Sunday again. How many things I can write like this? So don't you think like it will be like crazy?
At the top of the plane.
So due to
Yes.
this, we need to do it things in a much better way. How to better add it? Instead of you converting all of them and handling, so the best thing is like, so we can rely on converting the entire data type into something and use it. Means instead of all of them doing, where you are checking, are you checking with a lowercase? No, all were like title case. So convert here itself to title case. The result, what are you getting? Then half of the problem will be solved. Now you give like a SUNDAY or like whatever may, it will work. The same thing works even for Monday. You execute DAY, it works. So whatsoever way. And one more problem is that when you're executing, generally what if the user passes a white space? So apart from their value, they gave a white space also. So that's the reason whenever you're getting any value in runtime, we need to use this strip for like cleaning any white spaces. Unfortunately, if user enters. If I do like that, now it works. And if I give like, same Monday with a white space also, it works. This is kind of like a general cleaning, which is needed. So apart from this, the last point, that you need to understand is, what if you are giving some other value? Say I gave like, Friday, so or Tuesday. So why I got a mistake right now? I gave a spelling mistake. So spelling mistake is there. So, but you are not getting anything. If user is entering giving a something nonsense or like, random incorrect values, so we need to acknowledge. If you don't return in a result, it doesn't mean that it is you are perfect. So in this case, if anything is not satisfied, you need to have one case. For that, we need to use else case. So till now, else is not needed. Logically, if you need it, you use it. I found like, if anything is not done, that's where else will execute. So if I execute right now, you see now, if I give the same some random value, if I give, it will say invalid values. So now in this case, you understood that else is needed. So this is the beauty. This is where I solved one problem. So how to better solve this problem? So more than this way. So we can solve these problems in a multiple ways. So means like, if I take one kind of enhancement, every day we try to enhance our problem solution, right? So if you see like, whenever you are trying to optimize only, you will understand all the things. So the first way of optimizing is that we understood the same print you are using for all the values till Friday. So instead of you executing all of that, you define that particular constant outside and reuse it. So I wrote like weekday timings and I am repeating. So this is also a better way. If you do again Sunday, again Monday, so it will work in the same way. So like that, step by step we can optimize. Okay, this method is also good. But if I go one step ahead, as I did this much optimization, I understood that, hey, this is same for all the values. So for all these values, the result is same. So in this case, how to better address it? So there is one thing that, either this is correct or this is correct or this is correct. Means when I'm processing itself, I'm thinking, right? Either this is correct or this is correct, like that I'm thinking. Now, in the same fashion, in practically when I'm using also, I can reuse that concept. Means if this is correct, means if the week of the day is Monday or week of the day is equal to Tuesday. So like that I'm thinking, I'm saying. So instead of we doing every time, so I can just do like this. Week of the day is equal to Monday, or week of the day is equal to Tuesday, or like week of the day is equal to Wednesday. So this is what, right? We generally think on a human being, how we think. So that's why Python is interesting for everyone. So how a human being thinks in that language, only we can express directly. So as we have multiple things, I'm placing a brace. So I'm just removing it. Week of the day is equal to Monday or Tuesday or Thursday or so and so, you get the same answer. So if I say like, Monday right now, I got it. So it means like instead of doing like this, I can comment it. I can get the what exactly I want. I'm optimizing. See, I have like multiple, so relational operations and logical operations together. In fact, so with this, I could solve this problem. So if one more, if you can observe carefully here, totally how many operations are there? In this particular case, there were like 5 relational operations and 4 logical operations. And you know the concept of short circuiting means like it will not execute all of them. It will check for the first condition. That's, so short circuiting. Short circuiting means what? For like, our condition to be true, at least one of them should be true. It will check for the first true condition. If any one of them done, that's it. It will not go for all of them also. Same way like in if and condition we have. So, okay, sir. So this same problem we can also further optimize. For that, there is one more option called as a membership check. Membership check. Membership check means like we are checking for something is present within it or not. Any object iterable, we can check this one. So you are checking that the value should be this or this or this or this, right? Whenever this kind of operations you have, what we can do is like we can take what are the values you want into a list or a tuple or any iterable. I'm saying iterable means for now you can think like any object which supports for loop. As of now, like what are the values I have? All the values I want to take to a list. What are the values I have? I'm taking to a list. I have taken everything to a list, and you see what will I do now? Instead of equal to, I replace with a in. Whenever you are thinking like multiple things, so instead of this I can do, as it is a single time right now, I need not write to a different function and use it. I can just place it. So only once, right? It is, I wrote it. Now you see in this example, so instead of like multiple conditions and so in one shot I did. The same problem was solved. Now if I ask like Monday, I get it. If I ask like Tuesday, I get it. So means like I give a spelling mistake. If I execute again, if I give perfectly, I get it. So I can comment this option also. Now we understood. So in the process of evolution, I'm telling you what are the different ways of solving the problem. So in which case, which is optional, in which case, what is needed. So this is the journey I'm making you to go through. So with this, I want to stop. Before that, I want to give you one more assignment, which is like vowels and consonant. You need to take some value in runtime, and you need to check whether how many vowels are there, consonants are there. So you need to give me the constant. So how many are there, how many so and so. The simple operation in operator you can use, vowels and consonants with an in operator you can check and do it. Whatever I give, the same thing. So with this I want to stop. Any doubt?